Welcome, Applied Calculus students. In this screencast, we're going to take a look at how to use the power rule and the other parts of this particular section of your textbook to find derivatives for our Applied Calculus class. This will take no more than 10 minutes, Scout's honor. So let's find some derivatives. Let's find f prime of x if f of x equals x to the fourth minus 3x squared plus 5x minus 2021. Let's give it a go. Now you can tell when this video was made. So we're going to find f prime of x. What does that mean? Well, we're going to find the derivative, and we're going to find the derivative one piece at a time because minuses and pluses, the derivative of a sum is the sum of the derivatives, and that works just fine for differences also. And then we learned the power rule. We learned that when we see x to the n, that's nx to the n minus 1. And we learned that when you see a number in front, a constant multiple, we take the derivative of the x squared or the derivative of the x, and then we multiply by the 3 or by the 5. So the derivative of x squared, the derivative of x to the n, is nx to the n minus 1. The derivative of x to the 1 is 1x to the 1 minus 1. And then this is a constant, and we learned that the derivative of a constant is 0. So we clean this up nicely. Minus 6x plus 5, and we're done. Now, if we follow up on that, here's a quick side note. If we follow up on that to find the slope of the tangent to f of x at x equals 2, well, the slope of the tangent, that's f prime at 2. What's f prime at 2? Well, that's 2 to the third, that's 8 times 4 is 32, 6 2s are 12, this is 25. If we were to draw the line that ever so gently hits this curve just once at x equals 2, that line would have a slope of 25. This is how we use the power rule. This is how we use this lesson to find slopes of tangents. Well, let's go one step up. Find the equation of the tangent to y equals, let's do this, the square root of x plus 1 over x at the point 1, 2. We're going to find the equation of the tangent. Well, how can we find the equation of the tangent? Well, that's an equation of a line. I know how to find the equation of a line. It's y minus y1 equals x minus x1 multiplied by the slope. And that's where the formula comes from. That's the y value. This is the x value. And this thing is going to be the slope. Well, I learned on this screen that the slope of the tangent is a derivative value. So over here, we're going to find a derivative value. What's the derivative? Well, the derivative, that's tricky, isn't it? How do we write this in a way that we use the power rule? Well, the square root is the 1/2 power. So the derivative of x to the 1/2 power, that's moving this out of the way to be clear. This is x to the n, so the derivative of x to the n is n x to the n minus 1 plus the derivative of this thing. And how do we write this in a way that we can use the power rule? Well, 1 over x, that's x to the negative 1. And so when we find the derivative of x to the n, that's n x to the n minus 1. So cleaning things up a little bit, x to the negative 1/2 is an x to the 1/2 in a denominator, minus x to the negative 2 is an x squared in a denominator. So when we go to find the slope, at x equals 1, y prime is, that's a 1, that's a 1, negative 1/2. So we can find the equation of the tangent by finding a derivative and working from there. So it's super important for you to be able to write things in terms of powers. This stuff matters. So I'll go one more. Find g prime of x if g of x is x to the fourth plus 2x squared plus 5 over x squared. And you're thinking, come on, Rooter, we don't know how to find derivatives of quotients yet. That's not coming up till next week. I agree. But I think we can do this because this is a sum over a single denominator. So before we do any calculus, we can do a little bit of algebra. That's x squared. That's 2. That's 5 over x squared. Now we can use the power rule, right? G prime, the derivative of x to the n, that's nx to the n minus 1. The derivative of a number, that's 0. And the derivative of this thing, well, we're going to rewrite this thing in a convenient way. This is going to be 5x to the negative 2. And how do we take the derivative of 5x to the negative 2? Well, the negative 2 comes down in front, and the power goes down by 1. And so if we're cleaning things up, this is 2x. We don't need to write that. Minus 10x to the negative 3. It might appear in the back of the book like this, but it doesn't have to. Either of those forms is going to be acceptable for our class. It is important for you to know how to use the power rule. And it is super important for you to know that that's a power, that's a power, that's a power, and so are all of these, their powers. So before I leave you, let's find derivatives. Take a moment to make sure that you can find derivatives. Like hit the pause button. Hit the pause button. Make sure you can. The correct answers will appear in about 10 seconds. And there they are. I hope that you are able to compare your answers to these to make sure that they are right. Hope that this is helpful. We'll see you when we gather in class.